One wrong assumption about char can break your entire program. Signed, unsigned, ASCII, Unicode. Today we expose the hidden traps behind character types. Hey, welcome back. Fasten your seatbelts. We're coding clean C++ at full speed today. Now I'm going to uncover a sneaky C++ pitfall that seems simple but causes some of the most annoying and persistent bugs you'll ever face. We're talking about handling characters the right way. Alright, let's start with a very common scenario. Imagine you need to write a function that checks if a given character is a letter of the alphabet. It's a simple task and you might come up with a solution that looks something like this. Here's what's going on here. We have a straightforward function called checkIsLetter that accepts a single character. The key part is the if statement inside that's really the heart of the logic. It checks if the input character falls within the range from A to Z, or if it doesn't, it checks whether it falls within the range from upperclass A to Z. Now let's think about this for a second. This seems perfectly logical, doesn't it? In most systems you or I use every day, this will work just fine. And that's exactly why it's a problem. The code relies on a hidden assumption. It assumes that the letters A through Z and upperclass A through Z are arranged in two neat consecutive blocks in the system's character encoding. And this is where the problem starts. This assumption actually holds true for ASCII, which is extremely common, but the C++ standard makes no such guarantee. Your code could one day be compiled at a system that uses a completely different character set, like EBCDIC, which is still used in mainframe environments. In EBCDIC, the letters of the alphabet are not in one contiguous block. On a system like that, this code would completely fail for certain letters, leading to incorrect behavior. It's a portability nightmare waiting to happen. So how can we write this in a clean, professional, and most importantly, portable way? As you might have guessed, the C++ standard library has already solved this for us. Take a moment to appreciate how much cleaner and clearer this version is. The first thing we did was include the cctype header. This header is your best friend for all things related to character handling. It contains a whole set of functions for character classifications and conversions. Now look at our function. The if condition has been replaced with a simple call to the standard library function isalpha. The function's name tells you exactly what it does. It checks if the character is an alphabetic letter. The key here is that isalpha is guaranteed by the C++ standard to work correctly on any platform with any character set. It abstracts away all those low-level details. This code is now robust, it's portable, and it's self-documenting. Alright, let's move on to our second example. This is a solution you'll encounter all the time, handling user input for a menu. Imagine a program asks the user a yes or no question and expects them to type Y or N. Here's what's happening in this messy example. It prompts the user, readers, a single character and then uses a switch statement to decide what to do. The developer here was careful enough to check for both lowercase y and uppercase y, and the same for lowercase n and uppercase n. Now let's think about this carefully. What exactly is the issue here? While this code technically worked, it's a bit clumsy and error-prone. For every single option, we have to remember to handle both the lowercase and uppercase versions. Here, with only two options, it's manageable. But imagine you had a menu with 10 options or 20. It becomes very easy to forget a case. You might add a case for uppercase S to save, but accidentally forget to add one for lowercase s. This might look harmless, but here's the catch. This approach creates redundant code and makes the switch statement more cluttered and harder to read. It's a small issue, but these small issues add up, leading to code that's harder to maintain. So now let's clean this up by simplifying our logic. The goal is to make our switch statement as lean and simple as possible. Here's what's going on in this cleaner version. We're still including cctype, but this time we're using a different function, tolower. Look at the switch statement now. Before we even evaluate the case, we take the user's input and convert it to its lowercase equivalent. If the user types an uppercase y, the tolower function converts it to lowercase y. If they type a lowercase y, it simply remains y. Because we're normalizing the input before the switch, our cases become incredibly simple. We only need to check for lowercase y and lowercase n. We don't have to worry about the uppercase versions at all. This makes the code shorter, easier to read, and much less prone to error. We add new menu options. We only have to add a single case for each, which significantly simplifies maintenance. This is a much more robust and professional way to handle character-based inputs. And that's just one piece of the puzzle. Ready for the full picture? Check out my masterclass at alcoacademy.com. Don't forget, there's lots more on my channel too. Please leave a like and comment. I'd love to hear your thoughts.